here for them to develop the DATASTAGE tool. And after that, after completion of this tool, and when it has been released to the market, it has been acquired. The VMA, the entire has been acquired by the Informix. Actually, basically, the Informix is majorly for the database company, and it also, it also purchased the DATASTAGE from the VMA. And after that, after that, IBM has acquired the Informix, the entire company, but it has left the this DATASTAGE as separate, and it has just took the database, Informix database, and after that, this has been took by the Orchestrate. It's also the one of the company. Yes, after that, once again, it has been taken by the IBM, and it has renamed it as the Essential DATASTAGE. Okay. And after that, after a few years, like in 2001, it has been renamed to the WebSphere DATASTAGE. Again, the WebSphere is from the family of the tools, like it contains MQ, many tools like that. After that, finally, it has been renamed to InfoSphere Information Server. It belongs to now DATASTAGE is as part of the InfoSphere Information Server, IIS. We call it as IIS DATASTAGE. Basically, DATASTAGE is nothing but something like it's one of the mediator between the two sources. Like for example, we'll be getting, we will be having the sources from different in different formats. Like our source may be some books of the mainframes, or something like a notepads, or something like Excel sheets, and even from something like Oracle RDBMS databases, and whatever it may be the source. And our target will be one data warehouse. Like it's also the one of the table. And what we need to do is we need to combine all these sources, and we need to load into our final target using our DATASTAGE tool. So any doubts here?
No, go ahead.
Okay, fine. I know if you have any doubts, you can stop me at any point. Okay.
Okay, thanks.
Okay, thanks, Steven. This is the major functionality here, and in between moving from this source to the target, our DATASTAGE tool mainly does the main job it is to do the transformations. Transformation is nothing like something like we'll be getting the data from different types of sources. It might be having a different type of data types, and what we need to do is we need to bring it to the common layout.
Are you on the first slide? I can still see the first slide only.
Yeah, it's on the first slide.
Okay.
I'm just explaining about what the DATASTAGE tool does.
Okay. Okay. Okay.
You know, as a DATASTAGE developer, our basic concept or motto is to design the jobs in such a way that we need to transform the source data and we need to load into the target data. This transformation is nothing but the requirements which has been given by our client. The requirement that the SDLC is something like that. The business analyst of the client will be interacting with the DATASTAGE architect, and the DATASTAGE architect will get the details of all the source systems, and it will he designs something like architecture in such a way that different tables like these tables, these are the source tables, and it should go to this target table. The transformation should be like that. The DATASTAGE architect will send this document to the next levels, and then then as a developer what we need to do means we need to convert into the technical documents. Technical documents, it's something like it's more in detail about the technology. Like for example, we need to do the data type conversion, or something like a date conversion, or if we have some different sources, each different sources contains the different types of date formats. We need to bring all these date formats into a single format. So for that we will be using something like a transformer stage, for example. What we need to maintain everything in the technical document, like we are using this transformer here, we are using this function. We need to document in detail, and after that we need to design the code after the approvals. I think you are very well aware of the SDLC, right, Steven?
Yes.
Okay, fine. This is the part of the DATASTAGE developer. In DATASTAGE, we'll be performing the various operations like sorting, or something like removing the duplicates of the source data, and validating the data, something like using our aggregate functions like sum of, maximum of dates. And we will be having many operations that we use in the RDBMS or any database functions.
Yes, I have used DB2.
Okay, fine, fine. So you are aware of the DB2 and you have aware of Oracle?
Yes, I know about Oracle. I have not worked in Oracle, but yeah.
Okay, fine. The data stage, it's mainly the server. Mainly, it has been installed on the Unix machines. I mean, most of them are in the Unix boxes, and we'll be accessing them through our from other operating system or any type of operating system. Will be. I will show you the architecture. So the data stage, it will be, it's part of the IIS. As I said, data stage will be a part of data IIS. IIS is nothing but, I'm repeating, InfoSphere Information Server. It contains a different types of tools. I mean, all the tools has been integrated in this platform. It is something like a client server architecture. We can see here the client, and this is all. It is all in the, sorry. And this is in a server. It is the software which has been installed on the server. It contains majorly three: the services, repository, and engine. Engine is
Okay.
nothing but, I mean, yes, Steven, do you have any doubts?
No, I said yeah. Okay, go ahead.
Okay, fine. No, the engine is the major heart of the data stage. I mean, whatever the code we design, after that, when we click on the compile or the run button, the next step, from the next steps, all it has been taken care by our data stage engine. And these are services and repository is nothing but, I mean, these are all the separate things. I mean, the engine uses these services and repository for compiling, and for example, the services, it supports for the different, for all the functions which has been designed in the datasheet. For example, when we compile our code, the engine will contact the services for some functions, and it will contact the repository for the metadata. Metadata is nothing but something like table definitions, schemas, all will store in this repository.
Welcome to GoToMeeting, online meetings made easy. There are 2 other callers on the call.
Parallelism concepts. What happens here means, for example, for example, we have, as I said, we have something like a 10,000 records. When we click on the run button after designing our code, what happens means, this 10,000 records has been splitting into different.
Welcome to GoToMeeting, online meetings made easy. There are 2 other callers on the call.
Instead of waiting the transformation of all the 10,000 records, it will move the first 100 records or 1,000 records to the stage. I mean, it won't wait for complete staging of all the 10,000 records to transformer, and then it will transform. Again, it won't wait for completion of all the transformation for all the 10,000 records, and then move to the target. Did you got Steven?
Yeah, I got it. Yeah.
Yeah, this is nothing but a parallelism. IBM has been used the patented parallelism concept. Here we can have the 2 types of parallelism. One is something like pipeline parallelism. The second one is a partition parallelism. Pipeline parallelism is nothing but, as I said, it doesn't require. For example, see here. See the previously before implementing the parallelism concept. So this is the disk. You can think something like this is the disk. It is our source system. It will be moving to here, and after the first stage, again we should have some other database to store the data for this. After completion of this entire transform, then we need to start this enrich phase, like a transformation, something like that. After that, again we need to run this. Again we need to wait till all the rows has been processed. Then we need to start the loading here, and finally it will be moving to the target. But now using the pipeline parallelism, it won't wait for wait for the loading of all the 10,000 records. Soon after we get the 100 records or something like 1,000 records, it will directly move to the next stage instead of waiting here. This is nothing but pipeline parallelism. It is something like a pipelining from one stage to other stage. As soon as we receive the data, it might be a small 100 records or 20 records again. The second type is partitioning parallelism. As I said, as we have the 10,000 records, when we use the partitioning parallelism, it will partition our 10,000 data into something like a 10 sets, like 1,000. It's again depends upon the volume of the data and the mechanism what we use, or what we, in the sense that what the DATASTAGE developer mentioned during the job. I mean, while designing the job. Something like, it will partition in the data, and it will be moving from one part of the data to other part. And IBM, this DATASTAGE engine takes care of all these things, and it will be, we cannot see these things, but but we can observe during the runtime. This is the pipeline parallelism. These after combining the pipeline and partitioning parallelism. See here, the partitioning has been done here into 1, 2, 3, 4 sets, and after that, here you can see something like a repartitioning. Repartitioning is nothing but, for some of the operations we require the entire data. For example, we are doing something like a lookup of one record in all the entire 10,000 records. So at that time we require, all the entire 10,000 records. Why? Because as we just, look in the small set, we don't meet our requirements. So at that time, the repartitioning will be occurring here for this type of operations. Again, this will be done, by basing upon our code what we have been designed here. Yes, this is the 3-node partition. I said, the partitioning will happen. For example, we have the 3 nodes. The node is nothing but it's separate. We can think it's something like 3 separate subsets, or we can say, for example, we are having some we are something like a 4-tier architecture. We have 3 servers. We can think we can define each server as a one node. Node 1, node 2, node 3. In general, in all the production environments and most of the clients, they go for the 4-node configuration. It doesn't mean that they have the 4 servers. We can say that they have the 2 servers, and they can divide their disks into the 2 parts. One is and then they can define as a node 1 contains one part, node 2 contains the other part on the same server, and the second one will contain the other one. Any doubts still now, Steven?
Yeah, I have one question.
Yeah,
the partitioning, and if you go to the next slide.
Yeah.
I understand the partitioning and the repartitioning concept,
Okay.
but the criteria for partitioning and for repartitioning and where it will happen, all these are designed by the developer.
Yeah, one thing, the developer, he just needs, for partitioning, the DataStage, IBM provides the something like a partitioning algorithms and collecting algorithms. The DataStage developer, he just needs to mention what type of what type of partitioning we need to do. We have, for example, for partitioning algorithms, we have something like a key based or keyless. Something like a key based means something like hash partitioning, modulus partitioning. Depends. Based upon a single column, what we need to set. But it is not, if he doesn't know about, which partitioning we need to use, we have something like a partitioning mechanism, auto. Auto is nothing but the DataStage engine, it will be automatically, it will select the optimistic partitioning algorithm based upon the stage and based upon the volume of the data. We need not to, scare about this partitioning, all these things.
Okay.
Yes. It's part of the notes. You got this node concept, right?
Yeah.
Okay, fine. So this you see, this is the what when we design the job, we just, these are nothing but the we'll be calling this as the stages. This is nothing but the join stage. This is the aggregator stage, which is used to perform some aggregations like group by using the group by we can do some maximum of something. Many aggregation functions will be we can do using this stage. And this is the DB2 connector. These two are Oracle connectors. Here this is the source. This Oracle two tables are the source, and this is we are moving into the one table, and it is the DB2 database. When we design, it will be like that. When we run internally, it will modify into these things. It will be converted to like this. We cannot see this, but by using this parallelism mechanism, it will run like multiple instances. 4 instances here.
Right. Got it.
Production environment, okay, it's fine. Yes, configuration file. Now, configuration file is the one in which we define the nodes. Something like, as I said, in client, major clients are using the 4 client architecture. 4 nodes. See, this is the sample file which has been given here. Here, N1 is node, N1 name. Whatever the name we can keep, it's nothing like that. Just for understanding purpose, I just keep N1, N2, N3, N4. The first name is nothing but the S1, but nothing but name of the disk space or something like we can keep. We can say the name of the server here. 4 servers in the names of S1, S2, S3, S4. And resource disk and resource, we have 2 types here. Disk and scratch disk. Scratch disk is the main purpose is that we are saying to the DataStage, please use this /temp directory for scratch purposes, for temporary purposes. Why? Because when we run the jobs, it uses some buffer. It uses some buffer memory, and we are buffer space. So we are saying to the DataStage that please use this /temp directory for all these things. Okay.
Okay.
And resource disk is the main disk. For all the operations. And the configuration file is the one in which we need to. By seeing this, we can say that our DataStage architecture is a 4-node configuration, or 2 node, or 1 node, something like that. And
and these are all on Unix, right?
Not in Unix. We can see from Unix as well as our client. As I said, we have something like a DataStage director, DataStage the designer, and the DataStage administrator. No, we mostly
right. I'm saying the files are stored all in Unix, right?
Yeah, file is stored in Unix, but we can see from our designer.
Okay, got it.
Yeah, now I will be explaining partitioning and collecting, and before that, I will just explain what happens when we execute a job. Okay.
Okay.
Yeah. See, when we design, we'll be just creating some two. We'll drag and drop. We'll drag and drop the icons, and we'll be keeping on our canvas. And it will be like that. So what happens when we run? When we click on the run button, what it will happen means it will internally create something like a hash code. Hash code is nothing but something like similar to the byte code. Okay. Hash code. We have something like a all the parallel. Yes. Before that, I need to say we have something like a totally 3 types of jobs. One is the server jobs. One is the parallel jobs. Other one is the sequence job. Server jobs has been divided. Has been developed in 1995. As I said, it doesn't have the parallelism concept. So right now nobody is using this server job. Nobody is designing, but might be some of the clients using which has been designed. Before this IBM parallelism concept came. And the second set is the parallel jobs and parallel jobs. Parallel jobs is nothing but as with all the parallelism concept, it uses the parallelism concept. The other one is the sequence job. Sequence job is nothing but for one set we will be designing parallel jobs. Each parallel jobs contains some similar 1 or 2 or 3 functions. After that, at the final stage, we need to combine all these jobs and we need to create one sequence using the sequence job. So you got it right?
Yeah.
Okay. In parallel jobs, we have again, we have one stage. It's a transformer stage. It has been developed using the C++. Apart from this transformer, all the stages has been developed using the OSH script. OSH is nothing but orchestrate scripting language. You can say like that. When we compile this job or execute this job, what it happens means all the stages will become create some OSH code in backside, which is almost equal to the bytecode. And if we are using the transformer, it will again create some object code, and then after that it will create. It will be converting into the bytecode. Why I'm saying this means I just want to let you know about the transformer. It has been designed using our C++, and most of the best practices says that I use less as possible a transformers. Why? Because it will be something like a overhead for a DATASTAGE engine.
Okay.
Okay. Yeah, fine. And one more thing is, here we are able to see this arrow marks. As I said, when we compile, it will be generating the OSH script. When we see that script, for each link, it has been there will be some virtual files will be created in background for something for operations things. We can in the next classes when we run, I can show this script and I can show you what internally it happens. For a developer, it doesn't require to know all these things, but the thing is, when we see in the performance issue, for example, we can use many stages, and we can have multiple ways to do a requirement. But the thing is, the developer needs to choose the best stage. Why? Because at the development stage we'll be having the less data, so at whatever the way we use, it will be complete. It will be complete by within some 5 or 1 to 2 minutes. But the thing, when it goes to the production, it will be having will be reaching millions of data. At the time, it will be again a performance issue. So in order to identify which way is the optimistic way, we need to know all this script, and we need to know what is a virtual file and where it will be created and what happens. When we run this, we'll be having something like 2 operators will be created, 2 or 3 operators will be creating. If we design the job in another way, it will create something like 3 operators. So at the time, we'll be using this way. Why? Because we are reducing the performance. We are reducing the overhead here. Okay.
Got it.
Yes. I will explain you about the partitioning. Yeah, as I said that IBM provides us the partitioning algorithms and collecting algorithms. Partitioning is nothing but when we stand from source side, we are sending the data to the transformer phase in a different data in a different set of partitions. So we'll be dividing the data into the different sets using the partitioning algorithm. When we stand at the transforming side and we are looking for the data, we will be receiving the data in the form of different sets, and we need to collect them. So even for collecting, we'll be having the different algorithms here. So that is the collecting algorithms. You got it right?
Yes. Yeah.
Yeah. Yes. Partitioning. Yes. Yeah. These are all the partitioning algorithms. Round robin, random, hash, modulus, entire, same, and auto. Auto is nothing but, as I said, IBM provides this partitioning mechanism. When we use this, by default it will be auto. If until unless we know about the volume of the data and the type of operations we are doing, we need not to. When we know all these things, then we can keep on our own this partitioning algorithm. Otherwise, we can just left it as auto, so that the engine takes care of all these things.
Okay.
Yeah, as I said, even this algorithm has been divided into 2 categories. One is key based and the other one is a keyless, something like this is a keyless. Keyless is nothing while partitioning it doesn't use any key. It will be randomly moving to the different nodes. It will move for example first, third, fourth records might be in the first node, the remaining some of the records in second node, otherwise some of the records might be in third node. It doesn't use any key here. So any doubts here, Steven?
No, I'm good so far.
Yeah. The next one is the same partition. Same partitioning algorithm is nothing but okay. I will explain this later. You can understand yes. Entire partitioning. As I said, and before I said that when we at the time of at the time of explaining about the parallelism, I have been informed sometimes we require the repartitioning. For example, we are using the lookup stage for performance of lookup operation. We require the data to be entire data to be in each and every node. Why? Because we require while lookuping we need to search entire 10,000 records for even for one record. At the time we will use this entire partitioning. So you got it right?
Yep.
Yeah.
Okay.
Yeah. Next one is the hash partitioning. Hash partitioning is nothing but it's a key partitioning. It's based upon some key is nothing but we can keep one of the column as a key here. Based upon that key, this algorithm will work. The next one is modulus. It is also same as hash partitioning, but it takes something like it will perform the performance wise. Modulus partitioning. We prefer the modulus partitioning. Why? Because it is this is faster than the hash partitioning. No, this is yes. So this is the logic what this algorithm uses. Partition equal to mod of key value. Key value is nothing but the column which we are going to give divided by partition number. Partition number is nothing but we are using here. The example is for as a 3 nodes. So this value will be a 3. Key value is nothing but the value which the value of the particular column. Yes. Other one is the DB2 partition. DB2 partition is nothing but it has been designed for the DB2 stage. When we use the DB2 stage, then we'll be using this DB2 partition. Apart from that, we won't use that anyway. And one more partition is same partition. Yes. No, for example, we got a scenario in where we are using 2 lookups. One is 2 lookups. One after another. First, in first lookup we have given the entire partitioning algorithm here. Okay.
Okay.
Now we are in the second lookup stage. Again, in order to again instead of giving this partitioning as the entire, we can directly give the same partitioning algorithm. Same is nothing but it will just retains the current distribution. The current entire means all the records has been scattered in all 3 nodes. So N1 contains 10,000 records, N2, N3 contains 10,000 records. If you use the same partitioning, again instead of partitioning again using this entire mechanism, it will again the same data will be coming into the same nodes. So you got it right?
Yeah.
Yes, right. See, even here you can see the icon here. This means the same set of data goes to the same number of nodes here. Yeah, this is a sample one. Here this is something like a partitioning. This is a partitioning symbol. See, you can observe here it is collecting. It is getting data. It is being collected here. We will explain auto partitioning. This is auto partitioning. As I said, DATASTAGE. IBM has given this partition. Whatever. If you don't know about which partition we need to use, at the time we can use this auto partitioning mechanism. Yes, collector method. Collector method. These are the algorithms which we are using for collecting the data. Auto is fine anyhow. Round robin is nothing but we are picking the records from the different sets, different nodes into again to our stage. Ordered is nothing but it is nothing like first we are getting all the data from the first node, after that from second node, after that from third node. sort merge, if you require the output, while collecting, we require the data in a sorted, then we will be the first, in N1 will be getting sorted data, and the same N2 will be getting sorted data, N3 will be getting sorted data, and we will be combining all the data. Combining this, we will be merging all the data here. Yes, this is fine. My IBM DATASTAGE, okay. Yeah, as I said, we have DATASTAGE. It contains the server engines and parallel engines. Why? Because still some of the clients are using the server jobs for some operations. So when we are compiling server or running, server engine takes care of these server jobs, and our parallel engine takes care for all the parallel jobs. So types of jobs here: server jobs, parallel jobs, and job sequences. I will explain, why job sequences might be. Yes, I will explain with a simple example. For example, we are in such an environment that we will be receiving some files, some comma separator files from this mainframe stream. Okay.
Okay.
And the requirement is something like there is something like for each and every month, the entire monthly transaction should be coming to on a particular server in a particular folder. So I think so from mainframe guys, they will use some back programming, and they will send they will extract all the data for entire month, and they will send it to this job. They will send it to this server into a particular folder at that time. And after that, one more thing is with that file they will also send one success file or one control file. Control file is nothing but it contains the name of the file which they have sent, and it contains the number of records of that particular file. Now this is the first one, and the next, from then our DATASTAGE job, from our DATASTAGE job should be using these files, and it should be as it is a comma separated files. It should be doing some transformations, and it will be it will be calculating some amount, some paid amounts or something like that, and then it will be moving to some other data, something like a DB2 target. This is our requirement. In job sequence. In job sequence, what we'll be doing means, as the mainframe team, they have sent two files. We need to validate whether this file contains the exact record count, what the file have, and we need to see the file name. So for that, we'll be designing one job, and we'll be creating the second job for all the transformations on all the transactions. And third job, we are just loading this data into our DB2 target. For this, we have created the 3 parallel jobs, and we need to combine. The sequence is something like first one, second one, third one. Job 1, job 2, job 2. What we need to do, we'll be just creating the sequence job, and sequence job will be drawing all the 3 jobs, and we'll be giving the links. So this is the purpose for the sequence job. So you got it right?
Yeah.
Yes. Yeah. Okay. Fine. Do you have any doubts till now, Steven?
No. Some of the concepts are like I'm assuming you will go into deeper details in the actual course, so that's okay.
Exactly. Yeah.
But overall, I understand.
Yeah, you overall, you understand about what is DATASTAGE. So now you are able to, you are able to say that what is DATASTAGE and why we are using it. You know, right?
Yes.
Yeah. I will explain one more thing. So you were able to see this PPT, right?
Yeah.
Fine. So you are aware about what is data warehouse, what is all these things?
No, not much.
Okay, fine. It's not a problem. This is the normal data what we will be seeing in files. By seeing this, we cannot understand what this data is. And what we need to do means we need to change into this information. We can change by giving the column names, and it will become information. Here, so you can see that we will be calling this as the metadata. I mean, I think you know about the metadata. Data itself, data about the data. So this is nothing but customer ID. So for customer ID is nothing but a metadata. And these I know these all the open. These are by seeing this we can analyze this is what this column is customer ID. This is the date column. All these things we can get information whatever the informations may be the data. Might be the information in be something like a text file, something like a CSV files, Excel files, whatever it may be. The DATASTAGE can handle any type of sources. Even in the real time, most of the time, nowadays ERP is coming. So DATASTAGE supports to extract the data from different ERP systems, like even from SAP, SAS, many things, whatever it may be. It will be collecting all the data from different sources, and it will transform and it will load the target. We'll be loading all the data into the about this RDBMS, all these things, right?
Yes, yeah.
Yeah, why? Because you are reworking. Okay, I mean, how many? What is the experience? I mean, in year counts.
Yeah, I have 10 years of experience in DB2. So yeah, RDMS I understand
okay,
this.
Okay, fine.
Yeah.
So we can skip this. Yes. Okay. You know what is OLTP and OLAP?
No.
Yeah. OLTP is nothing but I mean the general all this. I mean what all the online transaction processing system. OLTP is nothing like that. For example, wherever even in banks, they store only the particular in their system. They will store only something like 6 months data or 5 months data or something like that. Why? Because again, I mean, whatever if you store the more data, and it will be again a performance issue for them. So what they will do means, I mean, in their night times, I mean, using a mainframe or something like that, they will move the data into a different server as a data warehouse for their archiving purpose or something like that. Yeah, these are some normal examples of OLTP system. Yes, problems with OLTP is not for reporting. Yes, it is for the daily processing. It's for not for reporting, not for analysis. OLTP system is nothing. For example, the major use of the data warehouse is nothing but for example, it is mainly used for it's a higher level people in a company. For example, we can say for a CEO, he wants the details, what happened, what are the value, what are the profits he got this year. And for example, we can say in a retail market, and the CEO, he wants to know what type of product has been gone this year, and based upon that he can he can provide to the stores in a sufficient quantity for the next year, and he can also know whatever the product has been less less in stock for this year, and what type of the product we are not able to produce to customers at the correct time, something like that. We want to analyze all those things. For that, what we need the entire data. For example, for entire year's data. So but he cannot store this entire data in a system. Why? Because he will be getting for each and every day the transactions might be very more, so the records might be very more. So what happens? So different source, and one we can again we will be having different scenarios. So for example, when we see the retail, retail stores might be in a different states. So they will be loading into a different table. So at the time, what they can use, I mean, at the night time, they will be gathering all the data, particular data warehouse. Data warehouse, by the name we can say it is something like a warehouse. It is something like a warehouse or godown which stores all the data. Based upon this data, we have the reporting tools. I mean, this data warehouse has been integrated with reporting tools. I mean, like a Cognos, business objects, CSAS, all these things. I mean, based upon this data, they will create something like a universes. Universes is nothing but designing the tables for them, and they will pull the data from this warehouse. So here we can see this. See, OLTP contains the entire detail. Detail thing. See, for each and everything here. And after that, finally, when we go to the data warehouse, it's very just summary for the entire single day. This product, this quantity, this price, this amount. It's very it's something like aggregated view. I mean, it is not the thing like we are just sending this aggregated one. we'll be sending entire data to our data warehouse based upon, I mean, what we can do some aggregation functions, and then we can pull the records in this format. And one more thing is, you know, okay. Yes, these are the three main concepts we need to, I mean, we need to remember, or something like that. You know, non-volatile. Non-volatile is nothing but non-volatile. We won't remove any even a single record from our data warehouse. And the second one is the time variant. I mean, time variant is nothing but, you know, we can get the data based upon our month, and based upon either on month or either on week or either on year or something like a quarter. And whatever the time we can do, we can extract the data further. Subject oriented. Subject oriented is nothing but, you know, for example, for a client, he might be having a different subject areas. For example, when we go to the healthcare, he might be having a different areas. Something like, for example, he might be having a paid, payable. He might be maintaining a, for example, even for the bank, we can take a customer has one subject area, accounts has been one subject area. For check payments, he can think. I mean, it depends upon his data warehouse capacity.
Got it.
Okay, fine. Yes, data mask. Data mask is nothing but, you know, it's a very, we can, as I said, in a subject area, we can maintain a data mart for each and every subject area. Data mart is nothing like, we can say it is a small data warehouse. And after that, we'll be, you know, we will be having something like a two data types, two types of data warehouse, dependent and independent, or we can call other things is, you know, first we'll be loading the data into the data marts. After then we can load it to the data warehouse. The other scenario is, first we'll be loading all the entire client's data into a single data warehouse. After then we can divide it into based upon our subject area.
Okay.
Yeah, this is the entire picture here. These are the different types of sources, and this is the ETL tool, like where here DataStage sits here. You know, we have, again, we have different types of vendors here. Many things: Informatica, Ab initio, DataStage, SSIS, and this is the data warehouse. Data warehouse might be on any database. Nowadays, most clients are, they are preferring the Teradata for that. The other one is the reporting. Reporting, we have again many tools, so Cognos, Business Objects, Microsoft, we have many number of tools, OBI, many things. And one more thing is, ETL. ETL means extraction, it will be transformation and loading. Extract is nothing but it will extract the sources data. It will perform some transformations on the data, and then loads to data warehouse. There are two types. One is ETL, other one is the ELT. ELT means extract. They will load into the data warehouse, and then they will do the transformations. Mostly most of the clients goes to the ETL, and nowadays some clients are going to ELT, and what they will do means, first they will load all their data into the Teradata, and the Teradata will is providing a many transformations concept in the database. It will be there using the transformations. They will be doing this all the operations like aggregating all these things, or something like removing duplicates, all these things. So you got it right?
Yeah.
Yeah, this is the entire project life cycle. Data profiling, data quality, after that ETL, after that MDM. MDM is maintaining the metadata. Now we are in this data stage. This is a small example. Okay, we have given ETL and ELT. Data extraction sources, ERP sources. Yeah, these are our client components. Other one is the server components. Designer, okay. Director, administrator. Other one is the web server console. It's nothing but using the web link, they can connect to the data stage. There is a sample screen while connecting to the data stage administrator. Here we can this is a sample screen. This is administrator's part. This is the designer window. These are all nothing but parallel jobs. We can the red color symbol is nothing but the parallel job. For server jobs, we will be having something like a green color, yellow color symbol. All the yellow colors are server jobs, red color are parallel jobs, and for sequence job, we will be having a green color for that. This is the aggregator stage, and this is the file. This is the sequential file stage. This yes, he is doing some aggregator transformation here. This is nothing but the director. When we run, we can see all the things. All the operations here one by one. Each and every step we can see here. When we get any error, this green will be going to the red, saying that aborted, and it contains the error message. And if we have any warnings, we'll be having something like a warning symbol, yellow color symbol. From when we click on that, we can see that warning message. Based upon this, we can check our errors and we can validate it. And one more way is we can also have the logs in our Unix server. Based upon that log also, we can do this error handling. Yeah, Steven, I'm done with today's content. So, do you have any doubts? You can ask me.
No, at this point, I don't think I have any doubt.
So, you are comfortable with this training, right?
Yes,
so
yes.
One more thing is, we require, data statements. The practice is must and should. Why? Because in each and every stage, we'll be having, for example, when we are extracting the data from a source, it might be, we can expect the data might be in a comma separator or something like a. The field separator might be a different one, either comma or something like a colon. Depends upon the source. For example, now we are using the sequential file. In sequential file, we will be having a different options. We need to remember that. Remember is nothing but when we do the practice, we will automatically be remembering them. Not only for that, even for we require the practice to remember them. So I just want to say that practice is compulsory here, and if you want, I can also give some scenarios to you. You can also work it on them in your free time.
Okay.
Yeah, that's all from my side. If you have any doubts, you can ask me.
Okay. Okay. Right now, I don't have anything. I will respond back in email.
Yeah, I think this organizer will be calling you. For this, I think.
Sorry.
The management team. I think they'll be calling you for all the things.
Right.
Things. Okay.
Right. Yeah.
Okay. Thanks, Steven, for joining. Thank you.
Okay. Thank you very much. Appreciate it.